So alright, we continue. We're going to give you the second example. You are required to sketch and identify a graph of polynomial function. We have done the first one. We know how to get the values of s of the function that will intercept the s axis and the turning point. Does help us to do what? To determine the type of graph which is likely to be a cubic. The first one we did a cubic function of the polynomial nature of the polynomial. So the second one is for the second example, f of x is equals to s raised to power 4 minus s raised to power 2. So you are required to sketch and identify this graph on this curve on a graphic paper. So to start with, we know that when f of x is equals to 0, this function s raised to power 2 s squared minus 1 is equals to 0. So we have that x is equals to 0 twice. Second is x is equals to s squared is equals to 1 and s is equals to plus or minus 1. So we have gotten the points, the s intercept of the curve on the s axis. Therefore, there are four intercept of, hope you are seeing it, 4 intercept of the curve. There are what? 4 intercept of the curve on the s axis. So we have 0, 0 when f of x is 0. When f of x is 0, s is 0 as well, as we have gotten it here. So the second is 0 again because it is 2, and the third is 1 and the what? 1 and 0, and the fourth is what? Minus 1 and what? 0. So there are four places where the curve called the s axis. Therefore, this type of graph, this type of curve is likely to be what? Quartic function. It's likely to be quartic. So we predict it's likely to be quartic because it has 4 points. So we proceed. The second thing we do is what? To find the maximum and the minimum point of the curve. We have gotten the intercept on the s axis. So the next is to find the maximum and the minimum point. At the maximum or minimum point, d of the function with respect to x will give us 4s raised to power 3 minus 2x, and at that point it's supposed to be equal to 0. The changing of the function with respect to x will be equal to 0. So with that, we can now find the value of x at that turning point. So this implies 4s raised to power 3 will be equal to 2x. So divide by 4x, we have x squared will be equal to what? 1 over 2. I hope you understand what we did here. Divide by 4x, we have s squared is equals to 1 over 2. So s will be equals to plus or minus 1 over what? Root 2. S will be equals to plus or minus 1 over root 2. So having gotten the value of x at the turning point, we can now find the value of the function at the turning point. When x is equals to what? 1 over root 2, put this value in this function. I hope you are seeing it. Put this value of x in this function to find f of x. So f of x will be equal to what? 1 over root 2 raised to power 4 minus 1 over root 2 raised to power 2. So we have that f of x is equals to what? If you simplify this, we have 1 over 4 minus 1 over 2. If you simplify it further, you have 1 minus 1 over 4 minus 1 over 4. So with this, we have gotten the first turning point at 1 over root 2 and 1 over 4. This is the first turning point. When s is 1 over root 2, at that point, the function is what? Minus 1 over 4. So we can now proceed. Are you following? I hope you are following. At any point, you can pause, ask question, then I will help you by providing the solution to it. So from here, we can clean. Pause the video, go through what we did. Can always pause at any interval to understand what we did here before proceeding. So we have gotten the first value of the turning point. That is, the first one now is 1 over root 2, 1 over 4. So when s is equals to what? Minus, we have used plus. So the next is to use minus. So when s is minus 1 over 2, you put the value in the function f of x is equals to minus 1 over root 2 raised to power 4 minus 1 over root 2 minus 1 over root 2 raised to power 2. You know the function. The function is f of s is given as what? S raised to power 4 minus s raised to power 2. This is the function. So you substitute this value. So f of x will give us what? This value. This will give us 1 over 4 minus 1 over 2. You notice that the f of x here is equals to f of x here, except that the value of y changes. Minus 1 over root 2 and here plus 1 over root 2. So this is equals to 1 over 4. So we have gotten the second turning point, minus 1 over root 2 and minus 1 over 4. So we have gotten all we needed to plot the graph. 1 over root 2 minus 1 over root 2 and minus 1 over 4. So these are values we need to plot the graph. Do you have any question? If you don't have any question, we proceed. Can I clean it? So I can clean this side. May not be smooth, but have any question? You may ask it before we proceed. This is the values which we use to plot the graph. All right. So these values we use to plot the graph. Because it's a sketch. So you draw the Cartesian axis. Here is si6, here is yi6. Note that this is equals to the function f of x. So from here we can begin, put point here, 1, 2, minus 1, minus 2. Here we can say it's 1. I hope you are seeing it. You can always jot the point down and then see how we sketch it. Here is 1. So we proceed. So from here, when s is 0, y is 0 at this point, because there are 2. So when y is 1, when s is 1, y is 0 at this point, and when s is minus 1, y is what? 0. So we have already gotten the point. The next thing is to look at the turning point. The first one is here, 1 over root 2. I hope you are seeing it. 1 over root 2. At that point, y is 1 over 4. So draw a vertical line here, draw here. They will meet somewhere here. No, this is straight. They will meet at point. So they will meet here. This is sketch. You draw the meet here. So the second is when s is minus 1 over root 2, y stay minus 1 over 4. So you draw here. They will meet here. So you have already seen how it may look. Use a smooth curve. Join the curve. Join the curve. So this is how it may looks. It looks like W. Is it not? It looks like a W. You use a smooth curve to join them, to join the point. So it looks like W. Most quartic curves looks like W. Sometimes it may looks like this. It looks like this. Are you seeing it? This is a type of quartic function. It may also look like this. Also it may look like this. Aquatic. It can as well look like this. Invert. Aquatic function. So this is aquatic. F of x is equals to s raised to the power 4 minus s squared. This is aquatic function graph. The aquatic function, its shape determined. So it has 2 turning points, and its shape, it touches the s axis at 4 points. You know, here is those 1, 2, 3, 4. 1, 2, 3, 4. So it's a aquatic function graph. So do you have any question? Remember the two I told you to plot, sketch, and determine their, give reasons why they are, reason for their curve, and then find the s intercept. Find the s intercept of the curve on the s axis. That is do this one. This is sig minus s raised to power 4. You can use the method I use. It is the same. D minus s raised to power 3 plus x. So do this one. Sketch it on a graphic paper. Determine the s-intercept of the curve on the s-axis and state the type of curve it is. Can we proceed? If we can proceed. So in this case, you can always pause the video, see the graph, and then before proceeding. Do you have any question? When let's say, if the function is equals to s raised to power 4, it will look like this. It will be symmetrical on the s-axis. So this is how it will looks like when f4 of x is equals to minus s raised to power 4 plus 1. If it is if the function is this, it will. This is the assignment to know. So when the function is s raised to power 3, it's going to look like this. It will pass the sorry. It will looks like this. So and so forth, and so on. For example, if here is negative, if we put negative here, you can always verify this how the graph looks like in a graphic calculator. You can always verify it. If we put negative here, it will look like this. This is how the graph will look like. So we can now proceed. Do you have any question? If you don't have any question, I assume we can proceed. All right. How to identify a polynomial function? How to identify a polynomial function. How do you identify a polynomial function? Recall that a function of the form g of x is equals to a in base n, s raised to power n plus a to base n minus 1, s raised to power n minus 1 plus a to base n minus 2, s raised to power n minus 2. If this continue until you get at this is plus a to base 1 x plus the constant. This continue until you get to the constant a. This type of function is said to be polynomial because each of its expression or terms has a variable in which its exponent is a whole number. The exponent of a polynomial function has to be a whole number. If it is a fraction or a negative number, then it is not a polynomial. You know, a polynomial is a constituent or many monomials joined together that forms a polynomial. So for this given function, where a to base n is not equal to 0, the leading function, this leading coefficients, where a to base n is not equal to 0, the exponents are all whole numbers and the coefficients are all real numbers. These coefficients are all what? This exponent n minus 1, n minus 2, like I've told you, is a whole number, and the coefficients, this coefficients has to be a real number. You know what is a real number? We have treated different types of number. Okay, so you have to know that the constants has to be what? Real numbers, and the variables exponent or power has to be what? A whole number. Do you understand? In this case, a to base n is what? It's called leading coefficients, because each variable has the highest what? Highest power. Each variable has the highest power in the expression. So it is the leading coefficient, whether it's 1, 2, 3 is the leading coefficients. N is equals to the degree of the polynomial. If the term with the leading coefficients has the highest degree in the given polynomial. So if a to base n, this is the constant term, it's called the constant term. It's called the constant term. So we can proceed. A polynomial function is said to be in standard form when its terms are written in descending order of exponent from left to right. So I can give you some type of polynomial we have. Do you have any question? I can give you a table of values of type of polynomial. So, and their degree, types, an example. A polynomial of 0, of order of 0, you can say is degree or order. A polynomial of degree 0 always is a constant. The type is constant. For example, f of x is equals to minus 1. This type of polynomial has a degree of 0. It's a constant term. Its leading term is sometimes its leading coefficient is equal to the function, that is minus 9. So 1 is called linear. A linear function, f of x is equals to x plus 7. It's a linear. Why is it a linear? It's a linear because the highest degree of the variable, the highest power of the variable is 1. So we have 2. Another one is 2. Are you seeing it? This type is called quadratic. Quadratic f of x is equals to, it can be minus s squared plus x plus 9. So I give you one more. We have 3. Degree 3. This is called cubic. So of the form s raised to power 3 plus s squared plus 1. So we can proceed. This is what different types of what polynomials we have. You can pause the videos, you see the type, the degree, and the example. As well, we have that if it is degree of 4, it is called what? Quartic. Example, s raised to power 4 minus s squared plus 1. So this is example and type of what? examples and types of what polynomial function we have in mathematics. So you can make a research 5, 6, 7, 8, their names, and how the examples of different types of the function they can form with respect to polynomial. So I can clean it. So when it is a linear, it has a degree of 1. When it is 2, it's a quadratic, it has the highest degree of 2. Therefore, the degree of a polynomial determines the type of polynomial. The degree of a polynomial determines what? The type of polynomial. Is 5, quintic, and so on and so forth. So the degree of polynomial do what? Determine the type of polynomial we have in mathematics. So we continue. Decide whether the function is a polynomial function. If so, write its standard form and state its degree, type, and leading coefficient. Decide if the function is a polynomial. If so, write it in standard form. State what? If you write it in a standard form, you state what? Its degree. State its degree, types, and leading coefficients. So in this case, you are required to decide if the functions is a polynomial. If so, write it in standard form. This is the first thing. State its degree. The second, the type, and its leading coefficients. So the first one is what? f of s equals to what? 7 minus 16 s squared plus 6x. The second is what? I hope you are following. The second is f of x equals to s raised to power 3 plus s raised to power minus 4 plus 1. The third one is h of x. It must not always be f of x. It can be h of s, g of x. So h of x is 3s raised to power 4 plus 2x minus 5 over x plus 9 s raised to power 3 minus 7 and 4. G of x is equals to s raised to power 3 minus 6s squared plus 3s raised to power 4. So do you get the question? Decide if the function is a polynomial. If so, write it in standard form. State its degree, type, and leading coefficients. So I will do number 1 and 3. Then you can now do number 2 and 4. So the first one, number 1, we are given f of x equals to 7 minus 16s squared plus 6x. So you are required to do what? To write it in standard form. The first thing in standard, the first is to do it in standard form. F of x is equals to what? To write a given polynomial in a standard form means to write each of the terms in descending order of power. In descending order of power That means the one with the highest power of the variable will be the first, followed by the second, third, and the last. So in this case, the term here with the highest variable power of variable is minus 16s squared. So you write it first. The second is what? 6x, and then the constant. The constant has no power. That's why it is an order of 0 or degree 0. Therefore, it is written lastly. So this is it, how it will be in standard form, or its standard form: minus 16s squared plus 6s plus 7. So the next thing is to state its degree. Its degree is equals to what? The highest, its what? Its power, or its exponent. It is 2, degree 2. So the third thing is to the type. It's quadratic. The quadratic function. It is what? A quadratic what? Function. I hope you are seeing it. It is a quadratic function. The third is its leading coefficients. Its leading coefficients is what? Minus 16. So what do you see in this example? Almost all the question is centered at the leading term, the term with the highest power of variable, and is the what? Where all the questions centered. In the standard form, it comes first, followed by the 6 plus 6s and the constant. Its degree is 2. That is the one with the what? The highest term variable. It is a quadratic function because of the power 2. Leading coefficient is what? Minus 16. So can we proceed? You can always pause the video, go through it. So the next is question 3. G of x is equals to 3s raised to power 4 plus what? 2x minus 5 over s plus 9x raised to power 3 minus 7. So by looking at this function, we know that like I have stated, I told you at the beginning of the lesson, a polynomial function is any function that has its terms or expression. Its variables has a power of what? Or exponent that has a whole number. Its power of each of its variable supposed to have what? A whole number. In the case that is a fraction or a negative number, not a real number, that function is not a polynomial function. Because I told you here, if this is equals to 5 over x is equals to 5 raised to power 5 times s raised to power minus 1. I told you for n not equal to minus 1, minus 2, minus 3. So here n is minus 1, therefore this is not a polynomial, because this is not a whole number. Here is not a whole number, this is a fraction. For you to know that this is a fraction, let s equals to 2. If s is equals to 2, you have g of x equals to 3 in bracket 2 raised to power 4. You are seeing it? Plus what? 2 in bracket 2 minus 5 over 2. So it is a fraction. Plus 9 in bracket 2 raised to power 3 minus 7. So this is a fraction, 1 over 2. Therefore, this function is not a polynomial and does not have any order. In as long as a function is not a polynomial, you cannot state its order. It is not a polynomial because this term, one of each term, that is this term has its function, function of its variable, not a whole number. It's not a whole number. Its variable is not a whole number. It is a fraction, and for that reason, the function itself is not a polynomial. So you can determine its other properties. So we proceed. You can now do number 4 like I told you, and number 2. If you have any question, you can ask me, then I will provide the answer for you. Can we proceed? Alright, we can proceed. We can proceed today. End behavior of polynomial function. How the end properties of a polynomial behave. It will enable us to determine how the graph of a polynomial function looks like. So, if you are ready, we proceed. End behavior of polynomial function. If you get it, we proceed. We are still treating mathematics. So there are some properties of a polynomial function graph you have to know in order to determine how the graph going to look like. So the first thing is the degree. When the degree is odd, the leading coefficients, the leading coefficient is positive. If the degree is odd and the leading coefficient is positive, we can determine how the graph is going to look like. The graph will look like this. So you see it, here is y axis and here is x axis. So when the degree is odd and the leading coefficient is positive, the graph will look like this. In this case, in this side, f of x, the function itself will tend to positive infinity as s tend to what? Positive infinity in this side. So here in this side, the f of x will tend to what? Negative infinity. F of s will tend to negative infinity, because you see the graph is going down as s. This is the negative side of x, as s tend to what? Negative infinity. So this will occur when the degree is odd. That is when the degree is maybe cubic, quartic, and all those negative function. It will look like this. F of s will be negative in this side, as s tend to be negative infinity, and positive infinity as s tend to what? Positive infinity. So but when the degree is odd and leading coefficient is negative, degree odd, leading coefficients negative. I hope you are seeing it. So in this case, we can draw the graph. Here is y axis, here is x axis. The graph will looks like this. It will tend to it will look like this. See the difference between the two graphs? If the degree is odd and the leading coefficient is negative, pointed at this side, so f1 of x will be what? f1 of x will tend to what? Positive infinity, as s tend to what? As s tend to negative infinity at this point. See, it increasing the function will tend to positive infinity, because this side has a negative values of x. S will tend to negative infinity. So at this point, the graph is pointing downward. Therefore, the function will tend to negative infinity. So because this is the positive side of the x will tend to what? Positive infinity. So this occurs when the degree is odd and the leading coefficient is negative. The end behavior of a function graph is the behavior of the graph as s approaches positive infinity or negative infinity. For the graph of a polynomial function, the end behavior is determined by the function's degree and the sign of its leading coefficients. As I'm trying to explain to you, the end behavior of any polynomial function is determined by its degree and the leading coefficients. So this will determine how the graph looks like. So if it's odd and negative, the function will tend to be positive when the function will be tending to positive infinity when the s is tending to negative infinity. Otherwise, the function will tend to negative infinity when s is tending to what? Positive infinity. So you have to know this condition for you to plot a polynomial graph or sketch it. I can clean this. So we can proceed. You have any question? All right. We are still on polynomial and behavior of a polynomial function. These are things you have to know in this part of algebraic section before we can proceed to other sections which you have in your syllabus. So the degree, the third one, when the degree is even and the leading coefficients, short form, is positive. If the degree is even and the leading coefficients is positive, we can sketch the graph. The graph will look like this. You know, this you have to use a smooth curve to join it. So it will look like this when the degree is even and the leading coefficients is positive. So that at this time the function at this part the function will tend to positive infinity as s tend to what? Positive infinity. So the function will tend to positive infinity as s tends to positive infinity, and here the function will tend to what? It tend to what? Positive infinity as x will tend to what? Negative infinity. This is a negative part of x, positive part of x. You know that I have told you before, this is a type of aquatic function. So lastly, when the degree is even and the leading function, leading coefficients is negative. If the degree is even and the leading coefficients is negative, we can still sketch the graph. We can determine how the graph is going to look like. So the graphs will look like this. Did you see it? This is how the graphs will look like. If you look at this, you see that different types of quartic graph. One is when it is degree is even and the leading coefficient is positive. The other one is when the degree is even and the leading coefficient is negative. So that at this point, f of x will be tending toward negative infinity as s tends toward negative infinity. If s tends to negative infinity, definitely the function will tend to negative infinity. So at this point, I hope you are seeing it, f of x will tend to negative infinity, f of s will tend toward negative infinity as s tends toward negative infinity. So these are the behaviors of the M behavior of polynomial function. So you can now proceed. Do you have any question? If you don't have, we can now proceed. Any question? All right, we proceed. I can now clean it. So, describe and evaluate the end behavior of the following graphs. You are required to describe and evaluate the end behavior of the following graphs. So we proceed. M behavior of a polynomial function. We are still on mathematics. Alright. Describe and evaluate the M behavior of the following graphs. Describe and evaluate the end behavior of the following graphs. So you are given the first one, f of x is equals to minus s raised to power 3 plus 3x squared plus 9. So at that time, s is equals to 4. So the second question, f of x is equals to s raised to power 3 minus 6s squared plus 3s raised to power 4. S is equals to 1. And the third one, f of x is equals to 0.25 s raised to power 3 minus s raised to power 3 minus 1. So at that point, S is equals to what? 1. Describe and evaluate the end behavior of the following graphs. So I'm going to do number 1 and 2. You do the 3. I will do this 2. So you can do this 1. So we proceed. I hope you are following. Describe and evaluate the end behavior of the following graphs. The first one, f of x is equals to minus s raised to power 3 plus 3s squared plus 9. So the function has to describe this function. The function has a degree of 3. The degree is what? 3. I'm describing in it, trying to explain it to you. The leading coefficients is what? Minus 1. I told you that the degree of any given polynomial function depends on the variable with the highest exponent of the variable. Depends on the term with which has the highest in which each variable has the highest what? Exponent. In this case 3 minus 3s has the highest exponent, which is 3. So the degree is 3 and the leading coefficient of this term is minus 1. Because the degree is odd, I hope I'm trying to describe what the question. So you will listen. Because the degree is odd, and the leading coefficient is negative, because the degree is odd and the leading coefficient is negative, f of s will tend to what? We tend to negative infinity, as s tend to what? Positive infinity. F of s will tend to what? We approaches, when I say tend, that is approaches. F of s approaches negative infinity as s approaches positive infinity, and f of x approaches what? Positive infinity as s approaches what? Negative infinity. So this is I'm trying to describe the end behavior of this given polynomial function. It is odd, it is a degree of 3, leading coefficient minus 1, and for such reason the f of s will tend to negative infinity as s tend to positive infinity, and f of s will approaches positive infinity as s approaches negative infinity. You can always verify this concept by using a graphic calculator. Go to this website, go to this website. All we have done, you can verify the graphs. Go to this website to verify the behaviors of the graphs, how the graphs will look like. www.mathway, copy it down, .com/graph. Go to this website to verify, to use a graphic calculator. I don't know if you have it. Since if you don't have it, you can go to this website, www.mathway.com/graph. At the left hand corner, at the left this side, you will see where you are told to enter the value, then enter this function. When you get to this website, you see where the right enter, then enter this function negative s3 plus 3s squared plus 9. Once you enter it, it will plot the graph for you immediately. You see how the graph will looks like. copy this website, go there and there, verify the graphs as the instruction is given. So having copied the website, I can now clean it. I hope you are following. Can ask question. So I do the second one. Second question, f of x is equals to what? S raised to power 3 minus 6x squared plus what? 3 s raised to power 4. S raised to power 3 minus 6s squared plus s raised to power 4. So we begin. You can rearrange it if you want. You can put it in what? In standard form. This will come first. 3s raised to power 4 plus what? S raised to power 3 minus 6s raised to power 2. So it's now in standard form. You can now interpret it. The function has a degree of 4. Degree is 4. Leading coefficients. Its leading coefficients, degree is 4. Leading coefficients is 3. And because the degree is even and leading coefficients is even, if you look at it, it's even. Leading coefficient is also even. Sorry. F of x will tend to what? F of s will tend to positive infinity as s tend to what? Positive infinity. And f of x will tend to what? Negative infinity approaches negative infinity as x approaches what? As s approaches negative infinity, as s approaches positive infinity. So you can go to the website to check this this concept, whether it is correct. So I have done what? I have described the nature of the two graphs. The next thing is to evaluate them. Can I clean the board? So we can evaluate the end behavior at the given interval. S is equals to 4 and S is equals to 1. So let's clean the board. So we can now evaluate the two functions at their given time, evaluate the end behavior of this function. So for the first one, evaluation for the first one, f of x is equals to at s equals to 4 minus in bracket 4 raised to power 3 plus 3 in bracket 4 raised to power 2 plus 9. So we now proceed. This will give us what? Minus 64. 16 times 3 will give us 8. Carry 1. 3 times carry 1. Mind you, this is 16. That is 16 times 3. If you times 16 by 3, you have what? 18 carry 1. This 3 times 1 will give us 3 plus 1, 48. So this gives us 48 plus 9. So you cannot add the terms. So f of x is equal to minus 64 plus 1757. So what do you have? F of x is equals to 57 minus 64 will give us what? This will give us minus 7. Is it not? 7, if you add 7 here, 57 plus 7 will give us 4, carry 1. 5 plus 1 will give us 6. So f of s is equals to minus 7 at s is equals to 4. So this is my first evaluation. Then let me do the second one. I hope you are following. If you don't, please ask question. The second one, evaluation. So f of x is equals to what? F of s is equals to what? F of x equals to what? At 1 raised to power 3 minus 6 1 raised to power 2 plus 3 1 raised to power 4. This gives us 1 minus 6 plus 3. This will give us 1 plus 3, 4. 4 minus 6 will give us minus 2 at s equals to 1. So these are two examples of description and evaluation of a given graph of a polynomial function at a specific point, at a specific intervals of x. So from what I did, I urge you to do this one. F of s equals to 0.25 s raised to power 3 minus s raised to power 2 minus 1. Describe and what? Evaluate the end behavior of the graph. Have any question? So we can proceed. Can we? So we proceed. Let's see if I can clean the board and then so let's proceed. Let's proceed.